Our group will going to share our blend navigation system with you. Before starting to introduce our blend navigation system, I will describe the related work first. By researching relevant domain, I know that the existing navigation system could help the blind as well as the visually impaired people in three aspects. First, sense the emergency for dangers and obstacles. Second, provide position and orientation information, and also provide optimal routes to destination. Here the video briefly introduces one of the related work, and here we go.
Blind Maps allows you to navigate and explore new routes with ease. The sonic environment provides vital clues on your surroundings, and although voice-guided GPSs work well, they take away from the ability for the visually impaired to get auditory feedback from the environment. It allows you to be aware of upcoming intersections, turns, and hazards en route. Wearing headphones and listening to a voice can be a dangerous distraction. With voice guidance, there is no practical way to get real-time and continuous feedback on your progress. Blind Maps is a crowdsourced navigation service which comes with a Braille-like interface for your smartphone and builds on top of the already existing functions of the phone in Google Maps. The visually impaired enjoy using smartphones such as the iPhone as it offers great voice recognition and audio output. If you experience a problem, you can report it with one button and the service will update your route and adapt to a safer route for the next user.
Well, this is one application in blend navigation domain called Blend Map. By researching the related work, we found one limitation. The system only deals with navigation service in outdoor or indoor, but not in the actual combined environment. Look at these two pictures. The first picture represents an outdoor service while the second one represents an indoor service. Our group developed a navigation system providing both outdoor and home mode, and they can be switched by using voice command.
In the following section, I will introduce the eye simulation system. This system consists of three parts: cloud-based data storage, portable device, and the application on the device. Before we get into the details of those three components, let's get to understand how the system works first. This is the system flowchart showing the relationships and the functionality of three parts. First, the database stores all the images of objects using to produce the recognition classifiers. There are two ways to obtain those pictures. One is uploading by system administrator or uploading by user's device. Second, the portable device captures the images directly ahead of user for application to computing. Last, the application generates the object classifiers through the database and combines the captured images to feedback the voice instruction to the user. That is how the system works. Let's come back to the details of three components. The first one, cloud-based data storage, is used to store pictures. Those pictures tagged with categories name are classified by their name. For instance, there are several images of different type of cup, which will all be assigned to cup category. In a system, the portable device could be some kind of smart glasses or a smartphone hanging in front of chest. The last one is the application. This application contains two modes: outside mode and home mode. Lacking guiding tiles in our environment tends to put the blind people under risk. Therefore, The first function of outside mode is providing guiding tiles. When user walks on the sidewalk, the application will generate the virtual guiding tiles. If the user steps out the range of guiding tiles, the application will warn the user and give instructions to guide him back. Another threat of walking route for blind people is across the street. There are two kinds of intersections when walking on the road. One is having the walk signal, the other is not. Our eye simulation system continues capturing images to process when the captured image contains a walk signal. The application processes the image, finding the signal, and then reminds the user there is a walk signal ahead, needing a cross street. Meanwhile, the system uses GPS positioning to overcome the condition that has no walk sign. When the distance between user and the road edge is lower than a threshold, the application also reminds user to be across road. Finally, the home mode is used to recognize objects inside the blind people's house. Before the first time using the home mode, the user needs to photo those objects which want to be recognized and uploads them to the database. Under home mode, the user says a command like find cup. The application will run object recognition algorithm based on the captured image. If not finding, the user can rotate for an angle and give commands again. These procedures should be repeated until finding the object or not finding the target in the space. All the above is the details of our eye simulation system.
Let's move on to this part, address the brief. Seize brief, enabling active decision-making for a safer future. In order to specify it clearly, we'll take into consideration the particularity of the blend and the risks it leads to first. From the psychological perspective, some blind people have difficulty in integrating into the society since most of the time they have no idea of where they are and where they are heading to, which could make them feel aimless, isolated, or even cause worse mental illness. On the other hand, from the physical perspective, when being outside, they are probably getting hurt due to stepping into the roadway or encountering obstacles without equipping with a navigation application. And even if being at home, the blind could get into trouble as well, due to the indoor space is relatively small and the blind are more likely hitting the wall, furniture, or door and missing a step when going upstairs or downstairs. These issues are all potential risk factors for the blind. Aimed at addressing the potential issues and enabling active decision-making for a safer future for the blind as well as the visually impaired people, we developed this navigation system. And according to the relevant survey and feedback from the users, we believe that our users and potential users can exactly enjoy more benefits and convenience that our navigation system brings. As a result, the blind could enjoy a convenient life, have more confidence towards life, and discover much joy in life. Then potential risks exist in their life will disappear gradually. Well, that's all of our video presentation. Thanks for watching.